What's going on? Today we are going to learn the very important law, which is Pascal law. So if you are new here, then don't forget to subscribe our channel. So let's begin. Before starting Pascal law, you should know the basic about Pascal's law. So Pascal's law is also known as the principle of transmission of fluid pressure. It was discovered by Blaise Pascal, which is a French physicist and inventor in the 17th century. So let me tell you about Pascal law. Basically, Pascal law states that when pressure is applied to a static fluid, static fluid means which is tough, not movable fluid, right? It is transmitted or distributed equally in all directions throughout the fluid. Okay, let me explain. When we apply a force in a static fluid, then the force will be transmitted equally in all directions. I will give you an example, then you will understand much better. Let me give. If I will draw a spherical container, right? And there is a piston which is attached to the opening point of the container. Let me make some holes in this container. According to Pascal law, if we applied a force or pressure, then the pressure will be applied equally in all directions of the container. I mean to say, at this point, the force is equal to this point, is equal to this point, and equal to that point. Every point will be equally apply force, right? The container is filled with any fluid. Mainly we should take water. Okay. So the formula is pressure equal to force of one area, right? Let me repeat again. When a pressure is applied to a static fluid, it is transmitted equally in all directions through the fluid. So we pushed or we applied a force, then the force will distribute it, so the water flows these holes in same force, right? So this is very simple, which is Pascal law. Let me give you another numerical problem, then you will understand much better. Okay? So this is the numerical problem. A downward force of 100 Newton is applied to a small piston with a diameter of 50 cm in a hydraulic lift. What is the upward force exerted by the large piston with a diameter of 4 meter? Let me make a diagram. This is the small container attached with a large container according to this problem. So we gonna to find the force exerted by this. So if F1 force will be applied, then the exerted force will be F2. According to Pascal law, we know that if we apply a pressure at this point, we will get the same pressure or same force at every point of the container. So P1 equal to P2. Let the force is P1 and this force is P2, which is exerted. We know the formula. P is equal to force of one area, right? Let me multiply A2 in every side, then it cancel. We will get F2 equal to F1 into A2 by A1, right? Okay, let me put the values of F1 in the areas. Okay, if I put the F1 is 100 Newton as the question is given, into A2. A2 is area of the large piston. So the piston is cylindrical. So the area of the cylindrical will be pi r square, right? And the second cylindrical shape area will be pi r square, right? So we cancel phi, then we will get F2 equal to 100 into capital R square by small r square, right? Let me put this value. R square, there is a diameter, right? And it is small cylindrical diameter and it is large cylindrical diameter. So this diameter we should convert into radius, and the unit we should convert into meter. So 50 centimeter will be in meter is 0.25, and this is 4 into 100, right? Yes or no? Let me write it 2. Okay. So 2 square is 4. So we write 4, right? Then the answer will be, if we calculate 6,400 Newton. So this is the answer, right? Will you understand? This is in diameter, we put in radius, so the radius equal to half of diameter, that's why we put 0.25. Understand? So this is the best numerical problem. If we apply 100 Newton force by this, then the exerted force will be 6,400 Newton. Imagine how much is greater than this. So generally, any shops or anything, our daily life, when we have to lift a heavy vehicle or a heavy things, we use in hydraulic pressure, hydraulic lift. That's why it is very important law for our daily life. Maybe you will understand. So thank you for watching my video. All of you, thanks. Tata, take care.